Diploma question, well, two-part diploma question that deals with titrations and redox reactions. So in this example, we are adding potassium permanganate to a solution of sulfur dioxide. So if we were taking a look at this, we would have our solution of sulfur dioxide in the Erlenmeyer flask, so the SO2, and there would also be water present here. And you're adding in the potassium permanganate, which is defined by that very, very dark purple color. So within this, the first part is an unbalanced equation, but before we even get into doing some calculations, it's asking us during the titration what we would observe. So the first one, an increase in acidity. This is going to be the answer, and let's talk about why. When we're looking at our reactants and our products, we do see that this H positive is being produced. So as this reaction takes place, we're getting more acidic, so your pH would be decreasing. Now, let's rule out the other three just to make sure we're right. B, a decrease in the solution of the volume. So our volume is what we're seeing in the Erlenmeyer flask, and you're adding in the permanganate. So you'd actually be increasing in solution, not decreasing. C, a decrease in the conductivity. Well, on your reactant side, you only see one ion. On your product side, you have 3 ions present. So that would mean your products, or as this reaction is taking place and you're getting more ions, you would be becoming more conductive, not less. So this one is not going to be correct. And the last one, an increase in the intensity of the purple color. Well, we do know that that permanganate is a very, very dark purple. As you're adding it in, it's going to disappear during the titration. It's not until the titration is done that that purple color would now start to change the color of our solution. So our answer for this first one is A. Now the second one, when we're actually doing a calculation, we are still using that same unbalanced equation, but to do a calculation, it needs to be balanced. So we're going to start by assigning our oxidation numbers. So we'll have -2, +4, -2 here. There's 4 of them, so -8. We need a negative charge, so Mn has to be +7. Oxygen, always -2. Hydrogen are always +1. On the product side, oxygen, -2, gives us a total of -8. We'll need sulfur to be +6 to get that charge of -2. And then Mn is +2 and hydrogen is +1. So now take a look at what's changing. Mn's changing from +7 to +2. That's an exchange of 5 electrons for every 1 atom, and there is just 1 there. And sulfur is changing from +4 to +6. So that's an exchange of 2 electrons, and there's only 1 atom. Now, to balance out of our electrons, we'll multiply this first one by 5 and the second one by 2. So we have an exchange of 10 electrons, right? Because we have to get our electrons to balance. So I'm going to put a 2 here and a 5 here, and then you balance the rest by inspection. So I'll put another 5 here and a 2 here. And I believe the only thing I need now is to look at my oxygens on the product side. There's a total of 20. 5 times 2 is 10, plus 8, so I'll need a 2 here, and then a 4 here. So now I have my balanced equation, and I do have other videos to show how to balance in a little bit more detail, but now that it's balanced, now I can start to arrange my information. So I have 150 mils of the sulfur dioxide, and I want to know the concentration of the sample. I also know that I titrated 31.5 mils of the permanganate solution, and you know the concentration of that solution. So before we go and start calculations, we do have to make sure that our volume is in liters. So just take those values and divide by 1,000. So 0.15, and then should just be able to do that in my head, but this one here is going to be 0.0315 liters. So our information about the permanganate can get us to moles, so I'm going to start with this. So 0.0315 liters, multiply it by the concentration. This step gets liters to cancel, and now you're at moles of the MnO4 solution. Now we can turn that into moles of the SO2 using the mole ratio. So 2 moles of MnO4 negative in the denominator, so the moles can cancel, for 5 moles of SO2 in the numerator. And then because it's concentration, when we're done, we want moles in the numerator, which we'll have, and we want to divide by our volume in the denominator. So to do that, just put it under 1. Once you have that, then you can enter this all into your calculator, which I'm doing right now. And I see that my value is 0.00525, and then this would be moles per liter. So if I wanted to turn it into millimoles per liter, I would just have to multiply by 1,000 because there's 1,000 millimoles in 1 mole. So that would get moles to cancel, and then I should see that my answer is C. If you did find this helpful, please subscribe and like the video. If I can do any other question for you, just leave me a comment and let me know. Thanks for watching.